Hello everyone. In this video, we will be talking about compound interest. Yes, but before we start, let's try to have some activities that might trigger your minds and your brains out there. This is a game, four picks, one word. Okay, let me clarify it to you that in every picture, press the pause before you answer, okay? Let's start. Four picks, one word. This is the first picture. Pause the video for a moment. I hope you will get the correct answer. And the answer in this picture is formula. Very good to those who got the correct answer. Let's have another one. Okay. What is that? Pause. And the answer is right. Yes. Let's have another one. Pause. And the answer in this picture, it is years. That's very obvious. Let's have the other one. Pause. And the answer is weekly. As you can see it there in the picture, you have a Monday to Sunday or Sunday to Saturday, and that's a week. And also in the other picture, you have it there Monday to Friday, so that's weekly. Let's have another one. Pause. And the answer is month. Let's have the next one. Pause the video. And the answer is time. Let's proceed to definition of terms. Let's start with compound interest. It is the interest added to the principal of an investment or a loan. Compounding. Compounding is the process whereby interest is credited to an existing principal amount as well as to interest already paid. So it is the process where interest is credited. For example, we have an existing principal amount, and then that principal amount, interest will still be credited to that one, even though it's already paid. Paid or not, the interest will still be included to that principal amount. That's compounding. Maturity value or future value, which stands for capital letter F. It is the amount after T years that the lender receives from the borrower on the maturity date. If you are asking about amount after T years, T represent here the year, okay? That's years. Now, for the formula of compound interest, we have to take note this one. For the future value, that's F is equal to P times the quantity of 1 plus I quantity raised to the power of N. And for the compound interest, that's interest is equal to F minus P, or future value minus the principal amount. Take note for this formula. You can write it down on your notes. Now, F stands for the future value. P stands for principal. Letter I, small letter I, stands for the interest rate. N is the number of conversion period or the total number of payments per year. Again, total number of payments per year. How many times are you going to pay within a year? Okay, in this example, We are going to compute and compare the future values in simple and compound interest on a loan at 3.5 interest rate annually after 4 years. So we have the same given, which is the principal, which is 50,000. The rate is 3.5% and time, which is equal to 4. Let's try to compute and compare the future values in a simple interest and in a compound interest. Let's see what will happen. Let's start with simple interest. We have the formula of the simple interest, which is I is equal to PRT. And therefore, we substitute there the given, which is 50,000 for the principal, 0.035 for the rate that's already converted to a decimal value, and the time from the given, that's 4. Therefore, if you're going to multiply all these values here and simplify, we will get 7,000 passes for the interest. And we're not done yet because we need to solve for the future value. Future value is equal to P principal plus the interest value. Therefore, we have 50,000 for the principal plus 7,000 for our interest. Therefore, the future value is equal to 57,000 pesos. How about compound interest? In a compound interest, we still follow the same thing for the first year. That's I is equal to PRT only for the first year. So that's times one. If you're asking, sir, why is it times one and not four? Because that's how we call it compounded annually. So per year, we compute for the compound interest. Therefore, 50,000 times 0.035 times 1 for the time, because let's start with the first year. Therefore, I is equal to 1,750. And for the future value, that's principal, which is 50,000, plus the interest, which is 1,750. Future value, we have 51,750 for the first year. Yes, because we still have more years. We have the second year. Second year, if you're asking, sir, for the principal, why is it 51,750? Yes, because since it's compounded, we're looking for the compounded interest and we are doing the compounding process. We are going to use the future value of the first year and make it as our principal value for the second year. Yes, that is a very vital thing here, that the future value for the first year will be the principal value for the second year. Therefore, I is equal to PRT for our formula. Principal is equal to 51,750 times the rate, which is 0.35 times 1. If you're asking why is it times 1, yes, we will still follow times 1 because that's only for the second year alone. Again, second year alone, that's only 1 year, right? So we will use 1. If you're going to say, sir, am I allowed to use 2? No, because we're not talking about 2 years, only talking about the second year, so which is 1 only. Therefore, when you multiply these values here using your calculator or any online calculator, we have I is equal to 1,811.25. And after that, we use this value in order to solve for the future value for our second year. And that's P plus I, 51,750 plus our interest, which is 1,811.25. When you add them, you will get 53,561.25 for the future value of our second year. And take note for our future value because we will use that as the principal for the third year. So here you go. So we are now using the future value of the second year as the principal value of the third year. And the same process, substitute the given principal, which is 53,561.25. Rate will be the same, 0.035, and time will be 1 because that's only for the whole third year. That's only 1 year, right? And I is equal to 1,874.64. Be careful for the decimal value, you need to include that one in your calculators, okay, in order to get the exact value here below. And we solve for the future value. Principal, which is 53,561.25 plus the interest, which is 1874.64. When you add both of them, you will get 55,435.89 for the future value of the third year. Take note for the future value because we will use that for our fourth year. Okay, for the fourth year, here you go. 55,435.89, which is the future value of third year, right? We use that as the principal of the fourth year. Then we substitute the given PRT. Principal is 55,435.89. And if you're wondering, sir, why do we always use or why are we using I is equal to PRT all the time? Yes, because it's simple interest. It's still interest. So this is the whole for this is a constant formula for interest, but it's a compound interest. Therefore, we change only the time, right? So that's 55,000, not just the time, but the basis of our principal, because the principal value will base on the future value of the past year. So this is the past year, which is the third year, and this is the next year, which is 55,000. So that's where we base our principal. Principal will base from the future value of the past year. Therefore, when you multiply here the given, we have that's 1,940.26, yes. And solving for the future value, we have P plus F is equal to P plus I. That's 55,435.89 plus 1,940.26. When you add both of them, you will get 57,376.15 for the future value of our fourth year. And that stops our compound interest for the future value. Now, let's observe the difference using the two formulas. So actually, we were using there the simple interest formula per year, but using the formula we had, so we have it here, F is equal to P plus I. So this is for the fourth year, right? And also the formula I've introduced to you a while ago, you have F is equal to P times the quantity of 1 plus I quantity raised to the power of N. You will get the same answer. Substitute the P, the basic, the first principal, which is 50,000, times the quantity of 1 plus its interest, quantity raised to the power of 4. If you're asking why is it raised to the power of 4? Because that's the number of payment within a year. Because we will be paying it for 4 years, which means that's one a year, right? So you have it there 4 and you will get the same answer. And if you're asking, sir, which formula am I or we are going to use? You can use either of the two, which you are more comfortable. But I suggest to use this one because it's easier in substituting the formula and it's more convenient. But if you're not, if you feel like you're not convenient with this formula, you can still use the per year. Solving it per year and you add them, that's how you do that. That's still okay. Now, this is now the table, complete the table as we solve for them. Future value for the simple interest for 4 years, that's 57,000. And future value compounded annually or compounded interest, you have it there, 57,376.15. There is a big interest, right? The same given, the same rate, and the same year, but the difference is quite observed here. As you can see, 57,000 alone for simple interest, but compound interest, that's 57,376.15. If you're asking what affects the future value of the compound interest at fourth year? Because every year we added the interest and we use the future value every year as the principal for the next year. As you can see here, pink there, and the future value here is used here, and the future value here is also used as a principal for the next year. And that's how you differentiate simple interest from compound interest. Let's proceed to examples of compound interest. First, find the future value and interest if 35,000 is invested at 5% compounded annually for 8 years. So try to analyze it well. The problem should be analyzed carefully. You should you should situate it carefully. We have 8 years. We have 5% compounded annually and 35,000 as our investment. Therefore, we have the principal, which is 35,000, interest rate, which is 5%, and N is equal to 8 because that's only annually and for 8 years. So we only divide 8 divided by 1. That's only, we paid 1 per year, right? So that's 8 years. So we paid 1 every, we paid 1, we paid once every year for the whole 8 years. So that's why n should be equal to 8. And we need to find f and I. Solve first for letter f. So I'm using here this formula that's equal to p times the quantity of 1 plus I quantity raised to the power of n. For p, we have 35,000 and then 1 will be constant plus our interest right here is 5% converted to decimal, that's 0.05, and n which is raised, which is 8. Therefore, you add it first, 1 plus 0.5, that's 1.045, 05 raised to the power of 8, that's 1.48. After that, you multiply it to 35,000, you will get 51,710.94 for the future value. How about for the interest? We need to solve first for the interest. Therefore, interest is equal to F minus P. You need to derive the formula. So I is equal to F minus P. Therefore, our F here is 51,710.94 minus the principal, which is 35,000. Therefore, our interest there is 16,710.94. So that is our answer, future value and the interest. Let's have another example. Miss Johnson invested 200,000 pesos in a company that gives 15,000 annual interest, compounded semi-annually. How much will she have after 4 years? And how much is the interest? You need to read it word by word, understand each word. Okay? So we have a 200,000 investment that gives 15% annual interest. So this is our interest rate, compounded semi-annually. You need to be familiar with that word, semi or semi-annually, which means half a year. And that's every 6 months. Every 6 months, you need to pay. So how much will she have after 4 years? And how much is the interest? Therefore, for our given, we have P or the principal, that's 200,000 pesos. And for our I, you need to use the formula for I, yes. For an I, which is not annually, as you can see here, this is semi-annually, you need to use J over F. J stands for the given interest rate, and F stands for the frequency. So how are you going to determine the frequency? By looking the word semi-annually. Remember, semi-annually is every 6 months. Therefore, from a year, that's 12 months. 12 months divided by 6, you will get 2. Therefore, semi-annually stands for 2. And you are going to simplify that for the value of our I. For our F, that's our frequency, right? Given, that's 2. And n is equal to 4, which is after 4 years. are now ready to solve for the future value and interest. We substitute the given in our formula. Therefore, the formula will be changed. As you can see, I here is the same, but we substitute J over F. And for our, as you can see here, we have N times T because it's not annually. If it's annually, we only have raised to the power of N. Since it's semi-annually, it should be N times T. T stands for the frequency, right? So since we're paying, so that's T is equal to F in this given. Therefore, we substitute our given to our formula. P, which is 200,000, 1 will be constant. J is 0.15 from 15% converted to decimal over 2 for F time raised to the power of 4 for the N times 2 for our T or frequency. And we are now ready to simplify. First, you simplify this one. So 0.15 over 2, that's 0.075. You add it to 1, that's 1.075. And then you raise it to the power of 8, you will get 1.78347786. Yes, you need to write the complete answer here because we're not yet in the final answer. Unless if we are on or in the final answer, you need to round it off. But it's not the final answer yet, so you need to write the whole decimal value here. Therefore, in this case, you multiply it to 200,000, you will get 356 and 695.57 paces. We're ready to solve for the interest, which is f minus p. We have the f here. That's 356,695.57 minus 200,000 for the principal. You will get 156,695.57 pesos for the interest. And that is the answer. Let's have example 3. What is the present value 50,000 pesos due in 7 years if money is worth 10% compounded annually? Again, what is the present value 50,000 pesos due in 7 years if money is worth 10% compounded annually? You need to understand it well. You need to situate the problem well. So from this given, we have present value 50,000 due in 7 years and worth 10% compounded annually. So that's only annually. So this is how we do it. For the given, that's 50,000 for the future value because it's the present value due in 7 years, which means a person is paying the past 7 years and that accumulates 50,000. And then the interest rate, that's 10%, and n will be 7. We need to find for p. Therefore, we need to uh, change the formula or derive the formula. And how are you going to derive that? Do it like this. So that's p is equal to f all over the quantity of 1 plus I quantity raised to the power of n. And then substitute our given. F is 50,000. Our 1 is constant. I is 10%. That's converted to decimal 0.10 raised to the power of n, which is 7. Therefore, you simplify. 1.0.10, that's 1.10 here. Raised to the power of 7, that's 1.9487171. And then 50,000 divided by 1.9487171, that's 25,657.91 pesos for our principal. That's how we solve it. Next, let's have example 4. Find the future value of 3,600 pesos if invested for 4 years and 6 months if the money is worth 9% compounded quarterly. Okay, this is another one. Compounded quarterly. So it will matter. So when you say quarterly, that's every 3 months. That's every 3 months. So therefore, we have P, which is 3,600, interest rate that's 9% or 0.09, and N is 4 years and 6 months. And when you convert that, that's 4.5. Why isn't it 4.6? Because 6 months, that's 12, that's 6 over 12, right? Which means it's zero point 0.5. It's zero point 0.5 if you're going to solve that one, because it's in a percentage. When you solve 6 months over 12 months, that is 1/2, right? Or zero point 0.5. So that explains why is it 4.5. Therefore, we follow this formula because our I there is quite, I mean, yeah, our I there should be in compounded quarterly, so it will matter also. Therefore, that's P is 3,600, 1 is constant, J is 0.09 over the frequency 4, because 12 divided by 3, because that's quarter compounded quarterly, 12 divided by 3, that's equal to 4. Therefore, raise it to the power of 4.5 times 4. If you're asking, sir, why did you write 4 first? It's okay because in a multiplication, you can interchange values, but you will get the same answer, okay? But you can still write 4.5 times 4 in the value of n times t, okay? It doesn't matter. Therefore, We simplify it. 0.09 over 4, that's 0.0225. And then you add it to 1, that's 1.0225. Raise it to the power of 18, that's 1.492587156. Multiply it to 3,600, you will get 5,373.31 for the future value. 5,373.31 pesos. Don't forget to write the peso sign because labels are very important. And that ends our lesson and example for compound interest. If you have further question, you can email my account. Thank you so much and see you again in our next videos.